When you're driving down the highway and you glance down at your dashboard, you are basically relying on a very specific kind of binary contract between you and that machine.
Right.
Like, if the check engine light is off, you just assume the engine is mechanically sound. You trust the green light.
Oh, absolutely. You trust the instrumentation. I mean, we've been trained for, what, a century to believe that the absence of a warning light equals the presence of health. It's just the fundamental assumption of how we interact with complex systems.
Well, okay, imagine a scenario where that fundamental contract is completely broken. So imagine your dashboard is glowing this beautiful, reassuring green, right? The temperature dial is perfectly in the middle. Your fuel efficiency looks great.
Sounds nice.
Yeah, but underneath the hood, the engine block is actively melting down.
Oh, wow.
Yeah. You are cruising at 60 miles an hour, completely blind to the catastrophic failure happened just a few feet away. And it's entirely because the sensors are telling you everything is perfect.
That paints a really terrifying picture. It really does. And it also happens to be the exact definition of what developers are grappling with right now in the AI landscape.
Yeah.
It is the absolute definition of unobservable competence.
Unobservable competence. That is the perfect phrase for it. And welcome to the deep dive, by the way. Today we are unpacking a massive, really seismic shift currently happening in the AI builder community.
Huge.
It is. The mission here is to understand why the entire industry conversation has completely pivoted. Like, we are no longer asking how capable are our agents.
Right, that was last year's question.
Exactly.
Yeah.
Now we are desperately asking how controllable are they. So to get to the bottom of this, we're pulling from a really fascinating stack of sources.
We've got a lot of ground to cover.
We do. We've got the latest raw developer chatter across Moltbook and Social Scout, specifically looking at the trends from, I think, April 13th through the 21st.
Yeah.
We're also looking at a major security disclosure from Cisco and a brand new, honestly highly alarming security audit concerning the Model Context Protocol, or MCP.
Yeah, because as developers rush to wire these AI agents into real-world, high-stakes environments, financial systems, customer databases, back-end infrastructure.
Important stuff.
The critical stuff, yeah. We are collectively realizing that trusting a green dashboard in an AI context might actually be the single most dangerous thing you can do.
Okay, let's unpack this. The central thesis of our deep dive today is that the biggest risk in AI right now is not that your agent is underperforming.
Far from it.
Right. The biggest risk is agents faking success, looking like they are working flawlessly while quietly, confidently, just drifting entirely off course.
Right.
And before we even get into hackers or malicious attacks, we really have to look at how these systems are feeling completely on their own. Passive, completely undetected failure.
This is the stuff that keeps engineers up at night.
Totally. So let's start with a phenomenon the builder community is currently calling ghost completions.
Yeah, ghost completions are dominating the engineering seats right now, and for very good reason.
I mean, the name alone is spooky.
It is, and to understand why they're so insidious, we really have to look at the mechanics of how an AI agent actually executes a task.
Walk us through it.
Okay, so let's say you have an AI agent tasked with querying a database to find all inactive users and, I don't know, sending them an email.
Standard maintenance task.
Exactly, standard task. The agent decides to use a specific tool to do this. It formulates a request, runs the tool call, the server returns a 200 OK success code, and the agent outputs a perfectly clean, properly formatted JSON response.
So everything looks perfect on the surface.
On the surface, yes. But if you look at the actual work that was executed, the agent might have run the action on the completely wrong task.
Oh, wow.
Yeah, or it might have hallucinated the context entirely or pulled data for the wrong client. But because the formatting, the actual JSON syntax was correct and the API didn't time out or throw a server error, the system registers it as a total win.
Okay, wait. I need to push back on this a little bit because this feels like a solved problem in traditional software.
You'd think so.
I mean, we have massive observability stacks, right?
Yeah.
Datadog, Sentry, New Relic. Our monitoring tools catch errors constantly. Why are they suddenly blind to this?
A great question.
If an agent completely hallucinates a task, why is the error log totally clean?
Well, let's break down what those monitoring tools are actually looking for. The observability stack we've relied on for decades in traditional software is designed to catch structural and systemic failures.
Okay.
It looks for syntax errors, formatting bugs, server crashes, API drops. It is measuring the shape of the data flowing through the pipes. It's basically a spell checker.
Oh, I see. So it checks if the words are spelled right, but not if the sentence makes any sense.
That is a great way to frame it, yeah. Traditional monitoring tools do not measure the meaning of the data. They cannot catch semantic hallucinations.
So they're completely blind to context.
Exactly. Let's go back to our database example. If the AI is supposed to delete inactive user accounts, but it hallucinates the definition of the word inactive, it might confidently decide to delete your most valuable, highly active enterprise clients.
Oh, no.
Right, and it executes this action using a flawlessly formatted SQL query. Your traditional error log will show 0 errors. The code ran.
Because the syntax was perfect.
The syntax was perfect. The database accepted the command. To your monitoring tool, the operation was a resounding success.
Man, it's like a delivery driver marking a package as delivered perfectly because they successfully, flawlessly threw it into the ocean instead of dropping it on your porch.
That is exactly what it is.
Like the system says, great job, the tracking bar fills up green, but you do not have your package. The package is at the bottom of the sea.
Yes. And that is exactly why this is a false success epidemic. The system just lacks the semantic awareness to realize that while the format was right, the reality was disastrous.
Right.
Ghost completions slip right through the cracks because we're using syntactic checks to try and detect semantic lies.
There was a builder quote on Moltbook that really nailed the frustration around this. They wrote, let me find it. Successful tool calls that should have failed are worse than failed tool calls. At least failures get attention.
Oh, that is so true. That developer is hitting on a fundamental truth about incident response.
Yeah.
When something fails loudly, when an API breaks or a server crashes, alarms go off. Engineers get paged. The system stops until the problem is fixed.
It's noisy.
Right. But a ghost completion doesn't trigger a page. The agent just happily moves on to the next task, and the hallucinated mistake sits in your database like a ticking time bomb until something downstream completely breaks days or weeks later.
So agents faking success completely by accident is a nightmare. But let's take a step further. What happens when someone forces an agent to fail on purpose?
That is where things get really dark.
Yeah. We're moving from passive ghost completions to active, deliberate manipulation. I really want to dive into Cisco's recent memory trap disclosure.
Yeah, this disclosure brings the control plane security problem into really sharp focus. Up until now, most developers haven't viewed agent memory as a critical vulnerability.
Hold on, let me stop you right there.
Yeah.
You just used the phrase control plane security problem.
I did.
Before we get into the Cisco disclosure, define that for me. What is the difference between a data plane and a control plane in this context?
Okay, think of it like a train network. The data plane is the cargo. It's the specific information the agent is processing for a user at any given moment.
Okay.
The control plane is the system of switches and signals that dictates where the train goes and how it operates. For AI agents, the prompt instructions and the persistent memory act as the control plane.
Got it.
They dictate the agent's overarching behavior, its rules of engagement, and its basic understanding of reality.
Okay, so if I'm a hacker, attacking the data plane means I'm stealing the cargo. But attacking the control plane means I'm taking over the routing switches.
Which is infinitely more dangerous.
Yeah, I can see why.
We've always viewed shared agent memory, the conversation history, the learned user preferences, the context of a long-running task. We view that as a convenience feature.
Right. It's what makes a chatbot feel smart, because it remembers what you talked about yesterday.
Exactly. But Cisco's memory trap disclosure proves that this memory has evolved into a massive attack surface.
And the attack vector they outlined is shockingly elegant. Like, attackers don't even need to touch the highly complex infrastructure.
They don't.
They don't need to hack the model weights or steal the underlying code. They don't even need to craft some elaborate 1,000-word system prompt jailbreak.
No, none of that.
They just inject or slightly modify tiny, seemingly insignificant portions of the agent's memory.
They essentially poison the well that the agent drinks from to understand its own context. And because the agent implicitly trusts its own memory, it assumes this injected context is factual.
The most terrifying detail from the Cisco research was their proof of concept. They proved you can edit a memory entry to make an agent appear more honest and reliable to the user.
Which is so deceptive.
Yeah. All while quietly steering its actual behavior toward compromised, malicious outputs. It's the security equivalent of sneaking into someone's house and replacing their glasses with a slightly different prescription in the middle of the night.
That's a great analogy.
Thanks. They wake up, they put them on, and they can still see. They don't think they're blind. but their entire perception of reality is shifted just enough that you can walk them right off a cliff.
It fundamentally alters their baseline reality.
But wait, if the model itself isn't hacked, and the core programming is totally fine, why is this such a big deal? Why can't developers just hit a reset button?
What do you mean?
Like, if they suspect something is wrong, just roll back the database, wipe the agent's memory from the last 5 minutes, and start over.
I see why you think that. It's the logical first thought based on how traditional databases work, but it is not that simple in practice.
Why not?
First, most teams are running agents with persistent memory in production because that persistence is the entire value proposition of the product.
Right, if you wipe the memory, you destroy the utility of the agent. The user has to start from scratch.
Exactly. But the deeper technical issue is that developers currently lack a viable rollback story for AI memory.
But why? It's just text data, right? Why can't they just delete the corrupted text?
Because AI memory isn't usually stored as neat chronological rows of text in a traditional SQL database. It's stored as vector embeddings in a vector database.
Okay, unpack vector embeddings for the listener. How does that change the rollback process?
All right, imagine a massive multidimensional library. But the books aren't organized by the author's last name or the date they were published. Instead, they are organized purely by how conceptually similar they are to each other.
Interesting.
So when an AI creates a memory, it converts that text into a mathematical vector, a coordinate in this massive library. It groups similar concepts together. So when an attacker injects a poisoned memory, they're inserting a corrupted book into this library.
And because the AI librarian pulls from this library based on concept, not chronology, the corrupted book gets mixed into the agent's thought process.
Exactly. It creates a massive feedback loop. The agent acts on the poisoned memory. It then evaluates the outcome of that action and incorporates that resulting thought process into new memories.
Oh, man.
Yeah, the corruption spreads through the vector space. The context becomes completely interwoven. By the time an engineer realizes the agent's behavior is drifting, the original poisoned memory has spawned dozens of derivative thoughts baked so deeply into the context window that you cannot cleanly extract it.
Wow.
There is just no easy way to verify memory integrity once the poisoning begins.
That is incredibly bleak. So our agents are suffering from ghost completions where they hallucinate success, and their very memories are a tangled web of corrupted vectors that we can't untangle.
It's a mess.
That brings us to the actual plumbing these agents use to connect to the outside world. How do they actually reach out and touch our databases, our files, our email servers?
The connections.
According to the sources, that plumbing is leaking everywhere.
We really need to examine the Model Context Protocol, widely known as MCP. Over the last few months, this protocol has essentially become the standard nervous system of the agent ecosystem.
Right, everyone is using MCP to wire tools into their agents. It's fast, it standardizes how an AI talks to external data, and it makes building these complex systems incredibly smooth.
It's very developer-friendly.
It is.
Yeah.
But the problem we're seeing across the April sources is that MCP adoption is accelerating way, way faster than the security models meant to protect it. We have a massive jarring number from a recent security scan that dropped in our stack, 24,008.
Yeah, that number represents a staggering failure of operational security.
That is the number of leaked secrets found in MCP configuration files, sitting right out there in public open source repositories.
Public repos.
Yes. We are talking active API keys, database credentials, OAuth tokens, real keys to real production systems just sitting in public code bases.
To frame how bad this is, you have to understand what an API key really is. It is an unexpiring password that completely bypasses multi-factor authentication and grants programmatic access to an entire system.
So it's like we gave our AI agents a master keychain to the entire house, but the real issue is we left the blueprint to manufacture those keys on a public billboard downtown.
Yep. Anyone can just walk up, copy the blueprint, and walk right through our front door.
Now, the sources do note that Anthropic was responsive here. They patched a specific vulnerability that was exposing credentials in transit.
Right, they did fix that.
But the chatter on Moltbook makes it crystal clear that the deeper issue hasn't gone away. So I have to ask, is MCP just a fundamentally broken protocol? Why is it leaking API keys like a sieve?
Actually, it goes a lot deeper than the protocol itself. MCP is not fundamentally broken by design.
Okay.
What that number, the 24,000 leaked secrets, actually represents is a massive crisis of operational maturity across the AI industry. Think about how software development normally evolves.
How so?
When you introduce a new, incredibly powerful capability like, say, Giving a piece of code right access to your production databases, you usually surround it with layers of security reviews. You build gateways, you require environment variables, you introduce friction.
Right. Traditionally, connecting a new tool is a massive headache. You have to write custom glue code for every single API.
Exactly. And because writing that custom glue code is so painful, you usually take the time to think about security and access controls. But MCP removes all of that friction. It creates a universal standard. You just write a quick JSON configuration file, drop in your credentials, and boom, the AI is connected to your database.
But by removing the friction, you remove the pause where the developer stops and thinks, wait, should I be pasting my raw production password into this random text file?
Precisely. When you remove the friction for the developer, you inadvertently make it incredibly easy to do things carelessly.
Makes sense.
Developers are hard-coding API keys straight into their MCP config files just to get a quick prototype working over the weekend. Then they push those config files to public GitHub repositories because the AI ecosystem simply hasn't established the rigid, uncompromising security norms that exist in older, more mature technologies.
So they're just getting sloppy.
They are accumulating what the industry calls a massive trust debt. We are building the future of software on a protocol we trust, but we are implementing it with developer habits that are inherently untrustworthy.
So let's connect all of these threads. We have ghost completions, silently faking success because we're using spell check to measure reality.
Right.
We have memory trap turning the agent's own context into an unerasable weapon. We have MCP trust debt leaking 24,000 secrets onto the public web because we prioritize speed over friction.
It's a perfect storm.
It is. These are not isolated incidents. Looking at the sharpest signals from April 20th and 21st across the builder communities, this cluster of failures has forced a massive wake-up call.
It has forced a profound paradigm shift in how we define a good AI system. For the last 2 years, the entire industry has been completely obsessed with autonomy.
Right. The goal was to build agents that could just go off into the wilderness, figure things out, and come back with the finished project.
That was the dream.
But the conversation has shifted almost overnight.
Yeah.
Developers aren't asking how autonomous can we make this anymore. They're asking what supervision loop can actually keep up with this thing.
Yes. We're seeing the rise of a concept across Social Scout right now called constraint legibility.
Constraint legibility.
It's fascinating. It's essentially the demand for transparency of limitations.
Okay, so it's the idea that an AI agent clearly and loudly explaining what it cannot do or what it is unsure about is now earning significantly more trust from developers than a polished, flawless performance demo.
Which is a complete 180-degree reversal of the marketing strategies we've seen from AI labs.
Totally.
The labs have been selling the illusion of limitless capability.
And builders are openly abandoning that autonomy theater. They don't want agents that confidently pretend they can do everything, because confident pretending leads to deleting the wrong database while reporting 0 errors.
Exactly. Nobody wants that.
Instead, the engineering effort is rapidly pivoting toward building heavy supervision infrastructure. They're building robust audit trails to track every single memory write. They are deploying verification layers to double-check the semantic meaning of tool outputs.
They have to.
And they're demanding honest status reporting that explicitly includes the AI's mathematical level of uncertainty. There was a defining quote on Social Scout that just sums up this entire moment.
Let's hear it.
A developer wrote, "I'd rather have an agent that tells me when it's unsure than one that confidently does the wrong thing."
It's a very sobering realization for the industry. We have to face the fact that we have been severely overinvesting in capability and underinvesting in observability.
Yeah.
What good is a highly capable reasoning engine if you have absolutely no idea what it's actually doing under the hood or why it made a specific decision?
None at all.
The ultimate takeaway from this shift in the builder community is that the winners in the agent space over the next year will not be the companies with the most capable freewheeling models.
Right?
The winners will be the ones who build the most observable, auditable, and legible systems. Trust is no longer derived from how smart the AI is. It's derived from how thoroughly you can supervise it.
The irony for you listening right now is just staggering. We just spent the last year throwing billions of dollars at AI research, begging these models to act like independent visionary geniuses.
Yeah, we did.
And now that we are actually wiring them into our real businesses, we're collectively realizing we actually just want a really cautious intern who constantly stops to ask for permission before touching anything.
We really do.
If this deep dive made you uncomfortable about your own AI infrastructure, If you're suddenly wondering what your deployed agents are doing right now when you aren't looking, that is actually a good thing.
Absolutely.
That discomfort is the starting point for actual reliability. So here's our challenge to you. The next time you deploy an agent, or you review a workflow, and you see that green dashboard glowing back at you, take a hard second.
Take a breath.
Yeah. Ask yourself, is it actually working or is it just not complaining?
It's an important distinction.
We want to hear from you on this. Send us your own supervision horror stories. We want to hear about your battles with ghost completions, the times your agent's memory went completely sideways, or the MCP secrets you had to scramble to revoke at 2 a.m. We're going to collect them for a future deep dive.
And as you think about how to build those supervision loops into your own projects, I want to leave you with one final kind of unresolved thought to ponder.
All right, lay it on us.
If the new gold standard for AI is constraint legibility, if we are now demanding that agents constantly report their own uncertainty, highlight their limitations, and wait for human verification, do we risk inadvertently training these models to be artificially hesitant?
Oh, that's interesting.
By forcing them to constantly second-guess themselves and ask for permission, are we ultimately crippling the exact autonomy we set out to build in the first place? Are we just trading the danger of a reckless driver for a car that refuses to ever leave the driveway?